Well, good morning, folks. Nice to see people here. For those who are in the room, it's very nice to see you. For those who are not in the room, it would be most helpful if people could say something on Top Hat about whether or not you're able to see me. Something seems to be a bit odd with YouTube Studio this morning. We had a technical issue with the preview last time, and it didn't seem to actually affect the stream, only the preview, which is very good. I'm having a different one. Okay, good. So people are saying in the chat can see. Excellent. Phew! So for those who are joining us online, again, there is an issue with the regular Top Hat chat, and that issue has now been reproduced by Top Hat, so they can see the issue, and now they're trying to figure out what the issue actually is so that they can fix it. In the meantime, in Top Hat, you should see a homework question, which is under the category administration, and that question is called pseudo chat. And so in there you can type things that are chat messages, and actually you can also upvote each other's things. So I'll put it here to most liked, and we'll see if people like each other's questions, then you'll be able to upvote them and they'll pop up to the top of my screen. So maybe that's also a useful way to sort of prioritize the questions that people might have. Okay, so let us start talking about something new. Unless anybody has any questions they want to ask first, whether they are online or in person. I'm happy to take questions either way. Love questions. All right, so I did see one, by the way, that came up earlier. Are the questions from March 21st and 16th going to get reassigned as homework? Yes, they should be. I did assign at least one as homework. If there's any that I've missed, however, you can drop me an email with the specific name of the question, because, again, Top Hat doesn't show me which questions I asked on which days. It just shows me, here's your, well, now you can see. No, people who are in the room can see, actually. It just shows me a huge list of categories and question names within those categories, so I don't actually get to see which question I asked on which day. So if there are any questions that you would like uploaded, if there are any questions that I need to assign as homework, please let me know what their names are. Someone says, does YouTube work for anyone else? It seems to work for some people. Hopefully it will come to work for you as well. Okay, so let's start talking about something new. And I've got so many windows open here in front of me. There we go. That's the one I wanted. So we're going to talk today about sets. So we have talked about lists. We've talked about tuples. We have talked about arrays. And these are all different containers. They are things that we can use to put other things inside of them. It's a value that contains many values, but there are some key differences among them. Lists are extremely flexible. We can do almost anything with them, including change them. Tuples are immutable, meaning what? Well, let's see how this goes with the fake chat thing. So what does immutable mean? Immutable means, oh my goodness, like 3 people just scratched their ears, one after the other. I mean, this is contagious. Immutable means that we cannot change something. Maybe I will try to see, I'll order these by the newest rather than, there we go. Someone says, the lecture hasn't started for me. Should I reload? Yep, try reloading. This is not as smooth an experience as we're normally used to. So immutable means that something cannot change. Yep.
It still says waiting on the YouTube.
I checked it a minute ago on my computer and it was like showing you.
Yep.
So
It still shows waiting for Jonathan Anderson online.
Try reloading and see what you get. Okay, at least one person said it's working now. A couple of people said they tried reloading and now it works for them.
it works for me again. I just checked right now.
Oh, okay. Did he start? Yep, he did. All right. So, yeah. Hopefully that'll work. Okay, working now. Excellent. So, and now we're kind of hopefully catching up. Let's take a look at those numbers. Oh yeah, we're starting to get there. We're now up to 17 concurrent viewers. Interestingly, my preview is still showing something wacky. Oh well. So yes, welcome. So we have talked thus far about lists and tuples and arrays. Lists are very flexible, but we can change them. Lists or tuples are very, very simple. And so when we want to have a collection of values, and actually we're not going to change the values, and we don't need to do a whole lot of stuff with them, then actually tuples are a really good choice, because when you work with simple things, then you don't have complicated problems. It's kind of like I was talking with a colleague today about temperature controls in our offices over in the new shiny new building, which computers are a bit like bacon. What do I mean by that? Does anybody know what I mean by computers are a bit like bacon? I could mean that in a bunch of senses. I don't mean they're typically very salty, although sometimes they make you a bit salty. So what I mean by that is computers are perceived as this thing that if you sprinkle them in anything, it makes it better. My vegetarian friends would disagree with this particular sentiment, but that's okay. So things like thermostats are now computerized, and there are lots of potential benefits that can come from with that. But boy howdy, there are also lots of potential problems. And so we now have issues in which I have a colleague in an office next to me who's freezing, and my office, when I close the door, gets up to 28 degrees, which is not great when you're wearing a sweater. So yeah, computers give us a lot of potential for nice things, but also the complexity that comes with computerizing absolutely everything opens up possibilities of harm. This is also true, by the way, as we apply computers to all kinds of other engineering systems that are not traditionally computerized, so industrial control systems, when we're thinking about like process systems in the offshore. So instead of a person having to turn a valve to make a thing happen, now we're going to have an actuator based on an AI algorithm that's running on a digital twin on shore. And so, you know, there's a potential for much faster feedback and control and more effective control. But there's also the potential for someone to break into your digital twin and cause bad things to happen. Factories with industrial control systems have been demonstrated to have caused fatalities because you can set equipment to operate in ways it's not supposed to, and workers have been killed. In a place, I forget the city in Germany, there was a factory where a piece of equipment was made to blow up and hurt some people who were working there. At a moment of great geopolitical tension that we currently live in, where everybody's worried about like cyber attacks and stuff, these are things we have to be concerned about. Did you know that the next big thing in the marine sector, for those who might be interested in ocean naval architectural engineering, you know what the next big thing is in the marine sector? Go on, guess. MASS, which stands for Marine or Maritime Autonomous Surface ships. So crewless vessels traveling around the world, in some cases controlled remotely and in some cases under their own control. And as somebody who spends their days thinking about security issues, boy howdy, there's a lot of opportunity there, right? And the reasons for it are clear, because if you can have no crew instead of 5 crew, or instead of 20 crew, you can save a lot of money on salaries and costs of keeping them in food and stuff. But also it means you don't need crew quarters, you don't need a kitchen, you actually don't need to meet some of the same safety standards because there aren't going to be human lives on board if the ship goes down. There's so many opportunities to have a more efficient or save money, basically. There's lots of opportunities there, but boy howdy, aren't there potential problems. So complexity is not always good. It is good to solve a problem in the simplest way that you can solve it while still getting the benefits that you are looking for. How does that apply to what we're learning here? So one, it means we should be a little bit careful when we think about, well, just add computers to everything, it'll make it better. That's not necessarily the case. But also, even when it comes down to things as simple as how do we select a data type that we should use in a Python program to represent something, simple is good. The simpler something is, the less opportunity you're going to give yourself to make a mistake and mess something up. Right. Okay, people are helpfully commenting online that if you reload the page, it should work. Super. Thanks very much for helping out, folks, because that means that I don't have to respond to all of those. So excellent collaboration, teamwork. So lists are kind of complicated, but not that complicated, but they let us do lots of things. Tuples are really simple, so where we can use a tuple, let's use a tuple. We've also seen arrays, so using NumPy or NumPy, depending on how you pronounce it, it's something that would allow us to have fixed size arrays, so we can't grow them, we can't shrink them, etc. We can change the values inside of them, but what's the other special thing about a NumPy array? What's the other limitation that means we can't do arbitrary things with it, but on the other hand, it means that we can stop ourselves from making certain kind of mistakes? What does it mean when I say that an array is homogeneous? Is it like homogenized milk? Comes in a red carton? Nope. So it says they taste good. There we go. So arrays taste good. Yeah, they're very close. Homogeneous means that they contain things that are all the same. So you can have an array of integers. You can have an array of floating point numbers. You cannot have the thing that you can have in a regular list where we have 1, 2, 3.14, and then the string pi. We can absolutely create a list that is heterogeneous, that contains different types of values. If we are going to do that in NumPy, however, and it's going to take a minute to import. There we go. If I'm going to create a NumPy array, however, all the values need to have the same type. And so we can see that this is an array. And if I try to create something like this, let's see what it does with it. Look, it converted because I passed in a list of values that had some integers and some floating point numbers. It said, no, 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 these all have to be the same type. So the array, the second array that I created here doesn't contain integers. It contains all floating point numbers because any of the values were floating point. And so that means a bunch of things. One, it means that you're not going to make a mistake of putting the wrong type of data in there. But also, it means that the computer can choose a very efficient representation for how to actually store that information in memory. It can say, I know how big each one of those floating point numbers is. It's 8 bytes. So if I'm going to have 1,000,000 elements in that array, I can just allocate 8,000,000 bytes in memory and boom, it's done. And I can jump around to absolutely any place in memory that I want to super quickly, and it can do a lot of really high performance operations. So it says, that was about computers and bacon, lol. Yes, excellent. Although that is about, I don't know, 5 minutes behind or so. So you may want to, maybe I should say this in the chat. If you're just joining the stream, you may want to click live to catch up to us. And hopefully that chat will be fixed soon. Okay, so what do all these things have in common? Anyone in the physical classroom? Yep, we are here. So what do all these things have in common? So here we have some attendance numbers, which, you know, are optimistic perhaps. We had a small number of people who were hanging out in the room, and maybe that'll dramatically increase over time. Hopefully not too dramatically actually, but maybe it'll increase, we'll see. We have some names of, these are first names of people who are in the course. I kind of randomly chose, and I actually used a random number generator to choose some names that start with A from the class. We have a lot of people in the class whose names start with A, but there's a lot of people in the class. Here we have some temperature values, and these are just kind of made up. I should have made them be my office temperatures, 26, 27, 28.3. So these things all have different types. They have different values, right? But what do we have in common amongst all of these things? Right, so all of these are homogeneous, that's right. So we've got a list of integers. We've got a tuple of strings, and we have an array of floating point values. So within each of these collections, we're using the same type for each of them. What else? There's a question in the chat. What does NumPy do? NumPy is short for Numerical Python. And so it's a package that gives us some flexibility to use things like arrays. And if you go back a couple of lectures where we talked about packages and plotting, I think I introduced NumPy there. Yeah, so they're iterable things. Yep, that's true. Someone says the YouTube is not working. It is working for some when they reload. Sorry. All right. So these things are all iterable. Yep. What else? Attendance is all even numbers. Oh yeah, good observation. That wasn't deliberate, but that's true. So it's good to be observant. Okay. One thing that all these things have in common is that these are all ordered collections. So for each of these, we can say element 0, element 1, element 2 within these, and they're expressed in a certain order. When we iterate over them, we're always going to iterate over them in a particular order. We can index within them. Say, I want to get element 3 from attendance, or I want to get element 3 from names, or I want to get element 3 from temperature. So all of these collections have an order. And in a lot of cases, that really matters, right? If I'm trying to track attendance over time, I would really like it if my list of attendance numbers was in fact in the right order and not just completely jumbled up, because if I'm trying to track, in this particular semester, maybe it doesn't matter so much. But there definitely could be times when I'd like to look at attendance over the course of a semester and see it's really good at the beginning, and then maybe it drops off a little bit when the semester gets busy. Then we're about to have our first midterm and poof, it shoots right back up. Or actually sometimes what happens is after a midterm it shoots right back up because people are like, oh, wow, this is harder than I thought. I better start coming to class again. And then it drops off when you've got huge presentations in 10:30 or something, right? And so I could track those over time. That wouldn't be very useful if I just had if I had those numbers in an arbitrary order. If I did a permutation and shuffled them all around, that wouldn't be very useful. Maybe here I'm trying to track who are the people who walked in the room first, or maybe here are the people who registered for the course first or something. The order sometimes matters. Notice anything about the names tuple that's different from the other things? Well, for one thing, it is a tuple. For another thing, it contains strings instead of numbers. What's something else that we might notice about names here? And actually, no, it applies to the temperatures as well. So something about names and temperatures that's different from attendance. So it says, oops, they all start with capital A. Yep, that's true. That is not true for the temperatures, but yeah. Someone says, anyone having trouble, try switching browsers. That fixed it for me. Okay. It could be a matter of clearing your cache or something as well. All right, what else? What do you notice about these names? So they all start with A. Anything else? Aha! There are repeated elements in both. Good. So we have some names here that appear once, and we have some names here that appear more than once. There's more than one Ahmed in this course. There's more than one Alexander. I think there's 3 or 4 Alexanders in this course. Apparently that is like the name of the semester. It's funny how from year to year these things will change. Like last year when I taught this course, we had 3 or 4 Graces, I think. And this year we've got 3 or 4 Alexanders, and it's kind of interesting to see the name. We have an Alexa in the course. So I think I haven't seen an Alexa in the course since, well, actually since my generation coming through. So it's coming back. All right, so there are repeated elements. And does that make sense? So if I'm trying to store names of students in the course, does it make sense to have repetition? Discuss. Okay, we've got a clear yes here, and I think yes. I mean, I guess it depends on what you're trying to do. If you're trying to track what are the names that exist in the course, maybe you might want to say no, but generally if I'm trying to keep track of 118 students' names, I would expect to have 118 names in my list. So yeah, it makes sense that there would be some repetition. How about these values? What's different here? There's a good question there. Can't you put a number next to the name? So on Friday, we will talk about another data type where if we wanted to keep track of names and how many of each there are, and keep track of both of those things for each name, then indeed there is another data type that we can use, which we'll talk about on Friday. But for now, let's just say it was a list of names, and it makes sense that there's repetition because we have more than one Alexander in the class. How about this one? What's different here? Going to get a little bit almost philosophical, but not quite. But it's okay. It'll be a safe journey. I am your guide through the land of philosophy. I have a Doctor of Philosophy degree, so not that I actually did a lot of philosophy courses or anything, but that's okay. Right, so we have different elements, yep. But also, there's something about these values which is a bit different. So if I want to keep track of the topics I'm covering on each particular day, and then at the end check which topics have I talked about, or which topics have I covered, or which topics have I addressed in any sort of a way. In that case, do I care that I talked about something more than once? Maybe not. Or if we're trying to keep track of, here are a bunch of rooms that have been cleaned on a particular day in the engineering building. So we have cleaned, somebody came by and cleaned 3029, which is half of the computer lab, 3028, which is my old office, 3023, and then they went to 3029 again. If we're trying to keep track of which rooms have been cleaned, we may not actually care that some of them have done more than once. Right? We're not really interested in the repetition. I just want to know, has this room been cleaned today? Yes or no? Actually, you know what? Maybe an even better example than that would be like if streets that have been plowed. So in the course of plowing all the streets in St. John's after a big snowstorm, some streets are going to get plowed multiple times because it's a street that the snow plows have to drive down in order to get other streets, right? So if we want to track that Allendale Road has been plowed, and then on the way to the Parkway in order to do Clinch Crescent, and in order to do, or Clinch Crescent and Arctic Avenue, and then they went down Allendale again to go somewhere else. We don't necessarily need to keep track of the fact that Allendale was plowed 14 times. We just need to know, was it plowed? Yes or no? What are the streets that remain that have not been plowed yet? So for those kinds of questions where we're interested in whether or not something is part of a set of elements, I've given away the game there slightly, haven't I? If we're trying to ask, has this room been cleaned, etc., then an ordered collection, which is very, very concerned about making sure we keep all of the elements you put in it and keeping them in the same order that we put them in, is not actually quite the right fit. It's not quite the thing that we need to solve the problem that we're trying to solve. Incidentally, let's say that we had, that we're trying to, so we did have this list, or in fact, let's do it the way that I just suggested. We have some streets that have been plowed, and that includes Allendale in order to get to Prince Philip Drive, in order to get to Arctic Avenue, in order to get to Clinch Crescent, and then they took Arctic Avenue back, and then Allendale in order to get to the Outer Ring Road or something. There we go. And I always misspell Allendale. There we go. So now we have a bunch of streets that have been plowed. Today is lecture 22. Okay. If I wanted to write a function that checks, has a street been plowed? How would we write this? Now, in this case, let's assume that we are going to access this global variable, and so this function is only going to take one. Actually, that's not very reusable, is it? So let's have it do both. Is street plowed? Streets plowed. So if we wanted to check, we're going to pass in both a specific street name and a bunch of streets that have been plowed, and we want to check, has this street been plowed? How could we do this? There's more than one way. So, someone who's either online or in the room, just throw out a suggestion which could be a part of the solution. Yep, so there's going to be an if statement in there somewhere. So we could have if name is equal to something something, then we could return true. Very good. How about that something something? Well, suppose we iterate over all of the streets. For street in, streets plowed. Typing in front of people. It's always tricky. If the street that we're checking is equal to the name of the street we're looking for, we'll return true. So we iterate through all of the things that have been plowed. Allendale, Prince Philip Drive, Arctic, Clinch, Arctic, Allendale, Outer Ring Road, etc. And then if the street we're looking for is one of those, then we'll return true. What if we don't find it after iterating through all those streets? Well, then we're going to have to return false. All right, so let's just run this function. So let's so here's our example, our list of streets. So I'm going to say is street plowed, and let's ask whether the Outer Ring Road has been plowed, and the answer is true. I could ask about Black Marsh. Has Black Marsh been plowed? And the answer is no, false. Somebody suggested in the chat a more efficient way to write this, or a way that involves less code at least, and they're absolutely right. So instead of doing this iterative algorithm and looking at each element, what's something even more efficient that we could do? Or even something, it might not be more efficient in the sense of it might work out to the same amount of the same number of operations being performed by the computer, but we have a higher level abstraction that these types have provided us. We can check each element manually, or we can ask it to do that work internally through however it does it. We could just return name in streets plowed. So that would be a quicker way, or a way that involves less code, more simplicity on our end, which is nice, and we use the abstractions that have been provided by us by the list type. Okay, so that's good. But, as we said, lots of times we are interested in a more existential question. Not existential in the sense of like Camus or Kierkegaard, but existential in the sense of does something exist or not? I don't care how many times it exists, I just want to know, does the thing exist? And this is where we can use sets. So if we have heard about sets in, I don't know, is it, probably haven't taken like a discrete math course or anything like that at this point. No. Okay. Well, things like sets and set theory, you've probably heard about intersections. You've seen a Venn diagram at some point. Yeah. So that is all about set theory, which actually might be in the high school curriculum in Newfoundland these days. There's some element of set theory, intersections and unions and stuff, maybe not. But a set allows us to store unique values. So, for example, if we want to know what is the set of students who are not promotable to term 3, that's an unfortunate set to be in perhaps, but there it is. And in fact, today, I hope that you'll be back either online or in person at 1 o'clock for the admissions talk that I'll be giving wearing one of my other hats. So if we're interested in the set of students who are not promotable to term 3, well, we don't really care whether they're in that set when we're trying to do the term 3 match. I don't really care if they're in that set for 1 reason or for 12 reasons, because they didn't finish chemistry, they also didn't finish physics, they also didn't finish math. I just want to know, are they in that set or not? And so we can call this existential storage of elements. Again, not because of philosophy, I am not that kind of doctor of philosophy, but because we are interested in does something exist in a set or not. And sets also, so sets will allow us to store things that are unique, which can be quite helpful because then there's sometimes less work to do instead of looking through all these duplicate entries to figure out, yes, I know you've already told me 14 times that Allendale Road has been plowed. I'm looking for the Outer Ring Road. Well, now we don't have to look at Allendale 14 times in order to get to the Outer Ring. So that's convenient, but also sets give us the opportunity to do interesting operations, mathematical operations that turn out to be useful for lots and lots of things in computing. So in math, if we were to talk about sets, you'd see something that looks like this. Let S be equal to, and then some list of comma separate, or some set of comma separated values. Well, in Python, it's going to look almost the same. We can take any iterable thing, whether that's a list or a tuple or an array, and we can pass it into the set function. So if I wanted to create, let's see. So now instead of just copying streets plowed that list into this new variable called example, I'm going to create a set from that. And now you will see that although streets plowed has Allendale, Prince Philip Drive, Arctic, Clinch, Arctic, Allendale, Outer Ring Road, our example just has 5 values, and there's no duplication, which is quite convenient in some cases. So now if I try to say, is Prince Philip Drive in example, well, again, that's just going to give me a true or false value, but it's going to be a little bit quicker in the way that it is able to check whether or not that value is contained in it. So in math, we can create a set like that, and in Python, we can create a set like that. We can also change the value inside of a set. So sets have methods, and instead of a method like append, what does the word append mean? Well, append means to put something at the end, right? Append. To put something at the end of a list makes sense because lists are very concerned about order. Sets don't care about order. You put things in a set, you're not necessarily going to get them back out in the same order. So instead, sets have methods add and remove. So if we come along and say, actually now I've plowed another street. What's a street in this neighborhood? Lark Hall. So we could have example.add Lark Hall, and now we'll see that Lark Hall is in there. And then we could say, oops, no, I made a mistake. I actually didn't plow Allendale after all. So I can, not add, going to remove. And you notice, even though Allendale was added 14 times, it really only existed in the set once. The first time we added it, okay, we've got a new value in the set. Every subsequent time, you said, yeah, that's nice. I already know that Allendale is in the set. You don't have to tell me again. And so it was only there once. So when we remove it, it disappears. So you can add something 12 times to a set and remove it once. Well, it's gone. Is set like a variable for a list. There are ways in which sets and lists are similar in that they are both containers for heterogeneous values, but they are also quite different in that lists will store all the things you put in, store them in order, and sets will only store unique values. Now we might say, okay, that's kind of nice, so we can add things to a set and we can take things out of a set. All right, very good. But so what? And then this leads to the other really useful thing about sets, which is performing set operations. And yes, this is a stained glass window in, I think it's the Royal Society building in London, and it is dedicated to John Venn, who was the inventor of the Venn diagram. And was also the president of, I think, the Royal Society from apparently 1905 to 1925. So if you've seen Venn diagrams, well, that's who they're named after. And so set operations that we can perform include union and intersection, but also difference and also symmetric difference. So these are 4 set operations that we should be able to perform either mathematically or computationally in terms of writing code. So the union of 2 sets is something that you've probably seen before. So if we have a Venn diagram that looks like this, and we have a set A and a set B, we can union them, and that gives everybody who is in either set or both sets, it's just everybody. So here's an example. If we are looking for, actually that code is slightly inaccurate, as you will learn about in the, I made a mistake there. This is a good example for a different slide, sorry. As you'll learn about in the admission seminar, this is not quite true. But let's say that to be promoted to term 3, you either had to pass your courses or have a good average or both. That's not actually accurate, but let's say it were accurate. Well, in that case, we could represent the union of those two sets of people who've passed all their courses and people who have a good average with the union operation. And you see the Venn diagram looks like this. The intersection, so in math, that's written, the union, you can remember it because it's written with a U, is the mathematical operation. The intersection is written with the opposite of a U. It's an upside down U. Now we're looking at people who are in both this set and this set. And that's actually what I should have said for my example. Got a little confused when I was updating all my Python examples. I put it on the wrong slide. The union, or the intersection, is actually what we're interested in. In order to be promotable to term 3, you need to both be in the set of people who've passed all their courses and be in the set of people who have a good enough promotion average. And so here is an example of, well, if we had, let me see if I can turn off some of those annoying sounds. It sounds like people are trying to send me messages, probably having something to do with admission stuff. Okay, so if we wanted to give awards to people who both are students with like high GPAs but also are demonstrating leadership potential in some way, well, we might have, here is, and these are made up student numbers, obviously not real students, we might have a bunch of student numbers of people who have high GPAs and a bunch of and a set of student IDs for students who are demonstrating leadership in engineering teams or whatever, whether it's the Killick project or Paradigm or this brand new one called Phoenix Aerospace, which sounds really awesome, and that actually I might be kind of helping out with a little bit by advising. And yeah, there are lots and lots of student projects that are going on through the Student Design Hub, so you should check out the Student Design Hub. But anyway, if you're interested, if we wanted to have an award for students who have both of these characteristics, we'd want the intersection of those two sets to get just people who fit into both of these. We can also compute a difference. So give me everybody who's in this set, but exclude anybody who is in this other set. So for example, sometimes we're very interested in thinking about students who are coming into the program. Here's the set of all the students for whom we gave an offer of admission. These are all the students who we said, yes, welcome, come to engineering, but for whatever reason, not everybody actually gets to make it because, you know, they have travel issues, or especially these days, people have had travel issues or visa issues, or they just decide to go somewhere else. That's fine too. So we take all the students who have been admitted to Engineering 1, and then the set of all the students who are actually enrolled in Engineering 1 courses, and if we take the students who are enrolled away from the ones who are admitted, what we're left with is the people who we then need to say, okay, why didn't these students show up? Was there a particular issue? Did they just go somewhere else? Whatever. So we can take a difference of sets. And so, you know, that's represented with a subtraction sign because, well, it is subtracting. It is taking anyone who's in this set and subtracting anyone who's also in this set. And then there's also a fun thing called the symmetric difference. And this is kind of another way of thinking about the opposite of the intersection. This is kind of like an exclusive OR. Well, in fact, it's very much like an exclusive OR. We are looking for anybody who's in set A or set B, but not both. So very much like an exclusive OR. So students who, yeah, I'm not sure that code example is actually accurate either. Sorry, I've confused myself by trying to prepare two presentations at the same time and thinking I could grab an example from this presentation and drop it in here, but maybe dropping it on the wrong slide. But the symmetric difference is just find me all the values in general, which in this case is student IDs, that represent people, all the values that are in one or the other, but not both. So here's a fun little exercise. Hopefully it'll be fun. It's an exercise. It's something that you should do. And you can do this by hand, and then you can do this with Python. So there are lots of different ways, as we've seen, of representing letters in the world. And given that I had, and so there are some of these letters. So the Greek alphabet is kind of a very historic alphabet that has lots of letters, some of which will look familiar to people who use Latin languages and English and other kind of European languages. And then there's the Latin alphabet, in which we write English and French and mostly German. There's some funny characters in there and stuff. There's also other languages that have character sets that are derived from an historic kind of Proto-Indo-European language and script, but have branched off in other directions in the family tree of languages, which is a pretty cool thing. But some of these things are in common, right? So this particular character that we would call a C, this exists in the Cyrillic alphabet, which is used to express Russian and Ukrainian, for two countries that are in the news a lot these days. But lots of languages in that part of the world are based on this Cyrillic script. But also, so the letter C appears in both of these. There are letters that appear in both the Cyrillic script and in the Greek alphabet. There are letters that appear in both the Greek alphabet and in the Latin alphabet. And then there's actually a whole bunch that appear in all three of these things. And so you can start by making a list of, here are characters that appear in the Latin alphabet, in the Greek alphabet, in a Cyrillic script. And I've given you, if you're not familiar with the Cyrillic script, then that's fine, but I've given you a link there. And so that's something where you can actually kind of compute these sets yourself by hand and try to figure, okay, which sets would this character be a part of? And you could draw a diagram that kind of looks like this to help you understand sets, but then you can check your work using Python. So create 3 different sets and then use different operations to say, okay, what is the intersection of the Latin alphabet with the Greek alphabet, for example? Which characters are in common? You've done it by hand, now check it with Python. See if you can find it that way. Oops, find it that way. So, I don't see any more questions have come in. I wonder if that's because the chat has stalled somehow. Anyway, I will flip that over now to show me the most liked responses in case there's anything I've missed. Interesting workaround. Does the YouTube work for anyone else? Okay, fair enough. So those are sets. So sets are not about storing things in an ordered way. Sets are not about storing things in a way that keeps track of all of the original values. Sets are about storing things that exist within certain categories and just checking, are they in that category or not? And then take things in this category and things in this category, and we can do interesting operations with them. You find the set of people who are living in Newfoundland and Labrador, the set of people who are 18 years old or older, and the set of people who are Canadian citizens. And you take the intersection of all those, and you find people who are allowed to vote in a provincial election. Right? The rules for a federal election are different. There are lots of other things where you might take the set of people who are Canadian citizens, the set of people who are Canadian permanent residents, find the union of those two, and then that group of people intersected with, do they live here, here, somewhere else? That gives other kinds of information about, are they allowed to do this, allowed to do that, etc. So sets can be really, really clarifying in terms of thinking about, and sometimes complex concepts, and also they're extremely useful in programming. I do write Python code that has to do things like find the set of students who are on track to finish Engineering 1. Well, what does that mean? Well, the set of students who have already completed all their requirements, the set of students who have completed almost all of their requirements, take the ones who are almost done, union together with the set of students who are enrolled in whatever they haven't finished yet, union those things together, then union these things together. That's going to give me a set of students who might be eligible for an early match in the spring semester, etc. So I actually do this kind of thing a lot. It's extremely useful. Use it all over the place. All right, but that is going to be it for today. Any other questions about this or anything? All right, well, if not, I hope to see you folks either back here physically or back here in a WebEx that Adrian has sent around the link for at 1 o'clock, where we will talk more about that Term 3 promotion stuff that everybody is keen to know about.